Good afternoon, everyone. We're going to get started. It's 1 o'clock. Today is day 1 of 2 for the Perimeter Air Monitoring Technical Guidance Training. Next slide, please. My name is Alyssa Ambacher, and I am with the Contaminated Site Remediation and Redevelopment Training Committee, and I'm here with Diane Hagman, who's also on the training committee, and we will be the moderators for today's training. Next slide, please. If you're here for continuing education credits, this course has been approved for 2.5 technical credits. There are some attendance requirements, so you have to be logged in for the entire session, and you have to answer all of the poll questions that will be randomly inserted into the presentation, and that's how we know that you were present. Next slide. All right, so once the training is over, DEP will provide the LSRPA a list of eligible participants for CECs, and then the LSRPA will reach out to you individually with instructions on how to access your certificate. And the certificates will be issued by LSRPA, not by DEP, and you will have to pay a $25 processing fee in order to get your certificate. Next slide, please. Right, so this is an example of our test poll. So these will be inserted in the presentation throughout. This is just an example, so you don't have to actually answer it, but when the test poll comes up, there should be a little pop-up screen that appears and you can select your answer. It doesn't matter if you get the questions right or wrong, you just have to answer. Next slide, please. And just to remind you, today is day 1 of the training. The other half is tomorrow at 9 a.m. And if you didn't register already, you have to register twice. So you would register for today and then register again for tomorrow. So if you haven't done that, make sure you do. And we also have a course evaluation, and that URL is at the bottom of the slide, and that will be dropped into the chat as well. We really look forward to all the course evaluations. They give us a lot of valuable information. So please be sure to fill those out. Next slide. All right, so there's a couple ways you can communicate with us during the training. There's a question box function and a chat function. The question box should be used to ask questions for the presenters, and the questions can be asked at any point, and they'll be addressed during the question segments that you'll see listed on the agenda. And we'll try to get to as many questions as we can during the presentation, but time can be limited sometimes. So if we don't get to your question, it'll be answered usually via email within a few weeks of the training. And just remember that the questions that we generally ask out loud during the training are short and not case specific. So we don't want to have too many site specific questions, try to keep it more general. And the chat function is also available, so let us know if you're having any technical issues. A lot of times technical issues can be solved just by leaving and coming back in. But please do not use the chat function to comment on presentations, to ask questions, or to answer other people's questions. Next slide. All right, so your job for this training is to participate. Ask questions if you want to, complete the poll so you can get your CECs, and then make sure you provide feedback on our survey monkey. Next slide. All right, so up next we have Bradley Muscle from the LSRPA.
Good afternoon, everyone. I'd like to first take some time and thank our diamond sponsors, as you can see on the panel in front of you. Next slide, please. Our gold partners. Next slide, please. Our silver partners. Next slide, please. Brief breakdown about some upcoming LSRPA courses and events. Aspiring Professional Services Series. There's 3 sessions, January 25th, February 1st, and the 15th, all focusing on different aspects. February 13th, LSRPA Virtual Regulatory Roundtable with Jordan Ash, Alex Saltzman, William Linder, and Ken Hayduck. February 15th, Site Remediation Licensing Board Rules Updates, and then 29th February, the Field Samplings Procedures Manual Training. Next slide, please. A few others in March and April. LSRPA Virtual Regulatory Roundtable about unmanned virtual aerial systems. March 19th, Remediation Funding Sources and Financial Assurance Training. Followed up by April 16th and 18th, Hazardous Waste Operations and Emergency Response 8-hour refresher training with Dave Sweeney. Next slide, please. Friendly reminder about the LSRPA conference coming up in April 3rd and 4th at the Hyatt Regency in New Brunswick. If you haven't signed up, please go ahead and do so. Next slide, please. Also, May, with the snow, May's a ways away. But Battle of the Bands, as a reminder, scholarship fundraiser. So please, that's with PCON and Society of Women Environmental Professionals. Please mark that down your calendar. Next slide, please. Stay connected on X, formerly known as Twitter, LinkedIn, Facebook, however you social media. Please keep an eye out there if you'd like to post things at various locations. Next slide. And I know it's January 23rd here, but please renew your membership if you haven't done so yet. Let's get an accurate count of who will be involved the next year. Next slide. If you're not a member of LSRPA, here's the link to join. It's a great opportunity to connect with other professionals, kind of know what's going on in the industry, and ask any questions, network, join committees. We're always looking for help. Next slide. That's it. Thank you very much.
Thank you so much, Bradley. All right, up next we have Alan Motter, who's going to talk about the history of perimeter air monitoring and a brief introduction.
All right, thank you, Alyssa. So as Alyssa said, my name is Alan Motter. I'm the Bureau Chief for the Bureau of Environmental Evaluation and Risk Assessment within the Contaminated Site Remediation and Redevelopment Program. It's probably appropriate that I talk a little bit about the history of this developing the guidance, because I've been working on this guidance for almost a quarter century now. I'd like to start off with the history. Actually, when I made this slide, we were going to do everything in one day on the 24th. So it's actually January 24th, 1984. Apple Macintosh computer goes on sale. It was the first commercially successful personal computer with a graphical interface and a mouse. I was a freshman in college at that time, and one of my friends got this computer, and we just thought it was the greatest thing. But nowadays, your cell phone could probably do a lot more than that computer could. Next slide, please. All right, so start off with introduction. Why do we need perimeter air monitoring? Well, one reason is that it's required by the tech regs under section 5.5B7, and it's been required ever since May 7th, 2012. And bear with me, but I'm going to read this first slide verbatim. What 5.5B7 states is a perimeter air monitoring and action plan to be implemented during a remedial action, if applicable, designed to monitor and control off-site excursion of dust, vapors, and odors. So there's a lot packed into this, so I'd like to pull out a few things. First is applicable. When is perimeter air monitoring applicable to your site? And this is something the committee considered very seriously. And we put a lot of thought into it. And Joanne Hell is going to talk in detail about applicability, but basically what we didn't want to do is make it such that every time you put a shovel in the ground, you had to do a full-blown PAM plan. But we also wanted to make it so that we'd be protective of off-site receptors. So I think we struck a pretty good balance there. And as I said, Joanne will give you more detail on that. The next thing I like to pull out is dust, vapor, and odors. So when we talk about dust in relation to perimeter air monitoring, we're really focusing in on respirable dust, that which can get into your lungs. So we're talking about particulate matter 10 microns or smaller, so what we typically refer to as PM10. And if you're not getting these terms, don't worry about it, because Dr. Prasadi and others will be elaborating on these concepts further down the road. I'm just trying to introduce a few things here. So we're talking about respirable dust. Although visible dust should not be leaving your site either, because if it's contaminated and visible dust is leaving your site, it could be settling on adjacent sites and contaminating those sites as well. Vapor, probably most people are quite familiar with the concept. Volatile chemicals in the soil can vaporize, volatilize, and become vapors in the air that can be inhaled. And then finally, odors. Odors is more of a nebulous concept because we don't really have a monitor for odors. It is more of a what is going to cause a nuisance to people because they don't appreciate the smells that are coming off of the site. Okay, off-site excursion. What do we mean by that? Is it when something leaves the AOC, when something leaves the site boundaries? And the answer to that would be yes. And I'm not trying to be facetious here, but sometimes you're going to be setting up your perimeter monitoring around an AOC. Sometimes you're going to be setting it at the fence of the site property. It depends on your site and site specifics. And as others go through the various steps, you'll see why sometimes it makes sense to put it at one location or another. But basically, what we want to make sure is that the dust, vapors, and odors are not reaching off-site receptors. And then finally, monitoring and control. So Bruce Groves is going to talk about monitoring. He has a whole section on that. And Erica will be talking about steps of monitoring and controlling dusts and vapors to prevent them from going off site. But basically, what we want to do is establish levels that if it's lower than that, we say it's acceptable. If it's above that, it's unacceptable. And those are the levels that we want to monitor, and we want to control to make sure that those levels are not leaving the site. The perimeter air monitoring plan will be developed during the remedial action work plan. So you should develop it concurrently with your remedial actions. So they go hand in hand. You're looking at your conceptual site model, developing a perimeter air monitoring plan that will complement your remedial actions on site. However, the documentation of the final PAM report will be in the remedial action report. And if the department is going to review it, that is the point at which it would be reviewed during the remedial action report. Next slide, please. Okay, so a little bit about the history. I stated that this has been going on for a long time. The perimeter air monitoring really, at least with the department, started to grow out of the coal gas site realm. And those of us who had coal gas sites, if you've ever worked on a coal gas site, it has a very distinct odor. Also has a lot of volatile chemicals which could affect people off site. And so routinely we would be doing perimeter air monitoring at coal gas sites. And so we wanted to come up with some sort of guidance to standardize it so that from site to site we were looking at the same types of monitoring. So we had an internal committee, and even when it was just an internal committee, it took us a while to complete it, but we completed it by 2010. However, it was requested that the New Jersey Science Advisory Board, or SAB, review this document before it was released. So the SAB reviewed it, and they completed the review in 2013. Trying to think of how to state this, but if we had implemented everything that the SAB had wanted us to, it would have been quite restrictive. And we felt that it would not be a viable program to put forward. And so we simply released the guidance as a draft along with the SAB charge questions and their responses. And that is the only guidance we had between 2013 and the end of last year when the PAM document came out. In 2017, we started an effort with the LSRP program, including NJDEP staff and stakeholders. I don't say this with a bit of pride, but it's the longest standing committee to produce a document. And the reason that that's important is there are a lot of complex issues that we were dealing with, and we put a lot of thought into everything, and we tried to come up with a reasonable guidance document. Also, between 2017 and the present, we had the pandemic hit, and that kind of put a hold on things for a while, but we finally got the guidance document out, and we are quite proud of what is in there. Next slide, please. Okay, two key terms that I would like to introduce here. Others will be elaborating on this. Joanne, Dr. Bersati, and others will be elaborating on these concepts as we go through, but I'd like to introduce them here just so that people are aware of them, because these are two terms that were developed for this guidance document and that are very important to understand in going forward. So the first term is health-based threshold values, or HBTV, not to be confused with HGTV, which is the network showing all the home improvement programs, but HBTV. So when we refer to that, we're talking about health-based threshold values. As the name would imply, they are health-based values. They are also time-weighted averages for the length of the workday, and generally workday is between 8 and 12 hours, depending on your particular site. But it's a value that is averaged over that workday. It is a not to exceed value. However, that doesn't mean you cannot exceed it in short term. You can exceed it in short periods of time. However, when you look at the average over the length of the workday, you should not exceed that health-based value. Okay, so that's the health-based value. The next thing is the response level. The response level is the value at which the instrument will be set to alarm. So why is that different? Well, a lot of times you will be using non-specific instruments, such as PID or FID for volatiles or dust monitor for particulates. They will be measuring, in the case of PID and FID, all the volatiles coming off of the site and not necessarily the one specific volatile that your HBTV is based on. So if you have a site that has BTEX, benzene, toluene, ethylbenzene, xylene, and your HBTV is based on benzene, you'll have to take into account that there are 3 other volatiles also present that will be causing your instrument to read. So your response level will be set somewhat higher than your HBTV, accounting for the fact that you're reading other volatiles that are out there. And we will get more into that explanation later. And I will be talking about a calculator later on, and we'll elaborate on that. Next slide, please. Okay, committee members. I didn't go through the original committee, but for the 2017, again, it took so long, we had a couple of retirees. Terry Sugihara was the original chair. Kathy Coons was our facilitator. Currently, we have myself and Erica Snyder, who are co-chairs with the committee. Amanda Gettelfinger with the department, who will be one of the PAM contacts on the contact list. Dr. Deb Bersati and Bruce Groves, who are both with Emilcott Triumvirate Environmental. Joanne Held, who was formerly with the department and actually worked on that original document back in 2001 to 2010, but it now has her own air toxics analysis services. And finally, Robert Scotto of Minich and Scotto. Next slide, please.
Thank you, Alan. We want to welcome Joanne Heldon. She'll be discussing the overview, intended use, and the applicability of the PAM guidance document.
Thank you, Diane, and thank you, Alan, for covering some of my material for me. It's good, always good to have a review, though. Good afternoon, everyone. I'm Joanne Held, and I was part of the guidance work group, as Alan mentioned, and retired from the DEP a number of years ago, actually 18 years ago. And this happens to me a lot, for those of you who are familiar with the workings of government, that things take a long time. So I continue to get calls from people saying, remember that thing you were working on? Well, we're getting back to it. And so when they said they're getting back to this project to develop good guidance for doing PAM, I was all in. So I'm really happy to have been part of this process. I'm also one of the site remediation on the site remediation professionals licensing board, where I've served since 2010 as one of the original members. But today I'm speaking as an individual, not representing the board. Next slide, please. My role today is to introduce you to the document. I will be covering, and subsequent speakers will go into detail about what's in the guidance. I'm covering sections 1 to 4 of the guidance, which cover these 4 topics. I encourage you to read these sections and not just skip to the details of the rest of the document. There's some really important points that are made there, and they give you context. Next slide. Within these 4 sections, you'll see some basic principles laid out that you should keep in mind as you're preparing and carrying out your PAM plan. First, there's the emphasis on real time and how to accomplish it, with laboratory analysis to corroborate the effectiveness of real-time monitoring. Second, there's a reminder that if you deviate from guidance, it must be documented. Next, a designated perimeter monitoring technician. Because of the intensive nature of a PAM program, it is strongly recommended that a full-time perimeter air monitoring technician be designated to carry out all aspects of the PAM plan. Next, it is assumed that sites where PAM plans are deployed have undergone critical review of all remedial options, and that the most appropriate remedial action strategy has been chosen and designed to minimize air emissions such as dust suppression, odor, and vapor control, use of an enclosure, other work practices. In other words, don't let the PAM plan be the way you tell if maybe some air pollutants are escaping. First and foremost, best practices to minimize air emissions. The PAM is to check to make sure that they're working. In this document, in many places, we remind you that attention must be paid to quality assurance and quality control. And then finally, odors must be addressed. The tech regs require that odors be addressed, but the guidance acknowledges that monitoring for odor substances is generally not feasible at the necessary detection levels. In this guidance, other approaches to odors are indicated in 2 places, one in the additional monitoring procedures under sections 5, and in the advice on air permit program requirements in section 7, including the possibility of odor management plans. Regardless of the chosen approach, it is important to document any odor complaints that occur during the remediation. Next slide. So why is this document needed? Alan covered this, that it's the tech regs require it. It says they must, the remedial action work plan must include a perimeter air monitoring and action plan to be implemented during a remedial action, if applicable, designed to monitor and control off-site emissions of dust, vapor, and odors. So this plan is developed. It's submitted with the remedial action work plan or the RAR. I sometimes get confused about which is which. And a reminder here that departure from guidance must be documented following the procedures in the Tech Regs section 1.5. Not all of the sections are applicable to every site, but be sure to note that in your documentation. of the elements that are not included and explain why. Next slide. So when does all this become applicable? Well, in general, guidance has a 6-month phase-in period, and so you must use this guidance by June 3rd, 2024. However, you may begin using this guidance immediately, and we hope you will. This option is encouraged unless you're already in the middle of a PAM program. We think that following this guidance will help you to do the most efficient and effective PAM program. And so we encourage you not to wait the 6 months until June, which is just a few months away now. So, but please consider that. Next slide. So the purpose of this guidance document is to lay out when PAM is required, to describe the steps to how to plan and execute a PAM program, to give guidance on how to evaluate data and take actions. It's really important that you have your actions. So you think about your actions in advance. If you hit a high level, what are you going to do? You need to not decide that on the spur of the moment. It has to all be laid out in advance so that you'll take the proper actions and be protective of public health. Again, the purpose, this guidance document also helps you to design a quality program, and also the guidance explains how to do real-time monitoring to assess the offsite impacts or the lack thereof, we hope. This is another really important part of this guidance that can lay that out for you. I should note also that any data collected in this program could be useful to inform stakeholders and the community of monitoring results where appropriate, and that's mentioned in a couple places in the document. Next slide. So, who does the planning? Who does the work? The term investigator is used in a generic sense in many documents of the CSRR program. Here it means an LSRP, a non-LSRP environmental consultant, or other environmental professional that is preparing the work and doing the work. It also, again, we strongly urge that there be a designated perimeter monitoring technician. It can't be left to somebody who just kind of casually goes in and gets the monitor started, and you hope they remember to check them. There should be a designated monitoring technician. And a reminder to LSRPs that in the board rules, it does say that an LSRP shall not provide professional services outside his or her areas of professional expertise unless they've relied on technical assistance from another professional who is reasonably determined to be qualified to do the work. And so we expect that to happen a lot with perimeter air monitoring, that if an LSRP is preparing the RAW, we'll have to bring in professionals who can help to plan and execute the PAM. Next slide. So what triggers the PAM requirements is to review what Alan described. Basically, it's remediation activities which with the potential to generate air emissions. Those could be things like excavation, grading, filling, compaction, dewatering, trenching, and treatment of contaminated media. Any of those things could generate air emissions. So it's required if the project duration is greater than 20 working days within a 30-month period. If you just have 1 or 2 days to get the work done, this is not going to trigger PAM. It's triggered when off-site receptors may be impacted, but given that this is New Jersey, I think you're not going to find many situations where off-site receptors aren't somewhere close by. Now, there may be an exception if a project is in direct oversight. DEP reserves the right to require PAM even if a site would otherwise be exempt. Next slide. Oh, I've got to test your knowledge. Diane?
Hi, everyone. This is the first poll question. And just to remind you that to answer all the poll questions, there's about 3 of them. And also a friendly reminder to fill out the Survey Monkey in the chat bar and else? Okay. So first question, is perimeter air monitoring required by regulation? And I'll give you about a minute.
Just a reminder, everyone, the poll needs to be answered in the quick poll window. So a pop-up should have appeared on your screen and you can select no or yes. Answering in the chat box or in the question box is not an acceptable way to answer. So make sure you are doing it in the poll.
The answer is yes.
Thank you, Joanne.
So on to my next slide. What the remainder of my talk is to give you an overview of the document, so you have a general context of what's in there, and the subsequent speakers will be going through a lot of this in much greater detail. So the first thing, though, in the document, after those 4 essential sections I told you to read, is the perimeter air monitoring plan development, described in 7 steps. We think these 7 steps are really essential to helping you put together a really good plan that will do everything you need and be very efficient as well. Another section is called Quality Assurance Considerations. Bob will be talking about that tomorrow. There's extensive information about how to have a good quality assurance program. There's a section called Additional Considerations, which I'll describe in a moment. There are a number of appendices, and there's also a PAM calculator, which I'll also describe in a moment. But it's important to realize this document will not tell you everything you need to know to conduct PAM if you've never done it before, but it will give you a framework to develop a good and protective plan if you are an air monitoring professional. And if you are not, it will help you to know what to expect in a plan and what questions to ask. Following these steps, I think, is the most efficient and effective way to prepare this comprehensive plan. Next slide. So here are your 7 steps. The first is to identify your contaminants of concern, which should have been done as part of all of your remedial action work plan. That's going to be a part of the normal process. And you should be well along the way in your process by the time you get to developing the PAM. Next is to identify the potential airborne exposures that could occur as a result of the chosen remedial action. The next step is to calculate your health-based threshold values and response levels, which Alan mentioned earlier, but to review, the health-based threshold values are health-based criteria derived using health-based targets that are set forth in the Brownfields Act and adjusted to account for the duration of potential exposure. From those, you'll develop your response levels, which are HBTVs adjusted to account for the capabilities of the selected monitoring instruments. You're not left on your own to calculate these. There is a PAM calculator that where you can plug in information about your site and will tell you what the HPTVs and response levels are. And Alan and Amanda will be describing that in detail later. Once that's done, the next steps are kind of logical. You identify the monitoring methods and technologies that will accomplish what you need to do. You will make a sampling and monitoring location and schedule plan. You will lay out the actions that you will use to address exceedances of the response levels and HBTVs if those are identified through, for example, confirmatory sampling. And you will there are steps related to your plan review, what to do if you have modifications, and how to be thorough in your documentation. Those are all laid out in this document. Next slide. So in the additional consideration section that I mentioned earlier, there's a section on analytical sampling, another section on real-time monitoring. There's some guidance on what to do if you have asbestos at your site. There's guidance on when you might need an air permit for the work that you're doing. There is a section on how to deal with hotspots, how to monitor while you're dealing with hotspots, and then a section on best management practices. Next slide. There are also a number of appendices. In addition to the normal glossary and acronyms, you'll find there's a appendix that lays out your PAM plan contents so that you can use it as sort of a guide, a template when you're putting together your plan. there's a section that has the equations used to develop the HBTVs and also what inhalation toxicity factors were used in that calculation. There's a section on real-time monitoring, another on analytical methods. There are a number of data quality objective checklists to help with your QA/QC. And then finally, there's a case study. And the case study will be presented at the end of the training today. It ties everything together and gives you almost a real-life example of how all these different pieces come together. And just as I said before, using these tools and processes and actions that are in the PAM guidance will aid the investigator in determining if off-site receptor exposures are maintained at levels protective of human health, and that's what we're all trying to do. So next slide. Thank you very much.
Thank you so much, Joanne. All right, and up next we have Deb Barsati for steps 1 through 3.
Good afternoon. I'm Deb Barsati. I have my PhD in pathology, and I'm a board-certified toxicologist with Emlicott, a triumvirate company. And for the last 30-plus years, I've been evaluating the effects of hazardous chemicals on public health and relating that information to the public. And one thing that I really want to stress is, Joanne alluded to, as did Alan, is what we're really trying to take the mystique or shine some light on what appears to be a black box that you can't quite see your way out of. And I'm hoping to do that when we're talking about the PAM steps 1 through 3. Could I get the next slide, please? Before I go on, I'd really like to take a little step back a minute and kind of go over Toxicology 101. Paracelsus is the father of toxicology, and he coined the term, all things are poisons, and the dose makes the difference. That's not an actual quote, but it's close enough, you get the point. And indeed, what it really says is everything can be toxic. So that is true. That's the principle of toxicology. And it's the important part, and what we are going to be stressing time and time again, is the dose, the exposure concentrations, and what can those that could produce harm. So we want to make sure that we can control against those, because if you stop exposure, you can stop toxicity or any hazardous effect that might occur. So that certainly is an important piece. So why this is important, Pam, I think you can figure that out. It's important because you want to protect human health. That's the bottom line. And so what we're going to be doing here as a kind of key piece of your perimeter air monitoring plan is determine what dose or what the exposure could be that would not cause adverse health effects. So you can stay below that with measures that you can put in place with your PAM to be protective of human health. Could I have the next slide, please? And as Joanne mentioned, the first step, and you should be well on your way to understanding by sufficient data. You're at this point in time, you've already pretty much taken a lot of samples out there, and you know what's there, and you've characterized just not only the delineation part, but using, is it hazardous, non-hazardous, and what chemicals are exceeding that you need to be cleaning up. And it's the focus, unusually, in a way, we oftentimes as toxicologists, you're very worried about ingestion and dermal exposure. But here, we're going to really focus on those off-site inhalation exposures. Because again, if you can manage those and maintain them under certain levels that are known to cause toxicity, you can reduce the risk. The target, obviously, as has been mentioned earlier, are volatile organic chemicals, or VOCs, along with semi-volatile organic chemicals, SVOCs. The inhalable particulate matter that Alan spoke of is that particulate matter that's equal to or less than 10 microns. And that is the type of particulate matter that you can actually inhale and get down into your lungs. and produce adverse effects. The other thing to be aware of is, you might have compounds that exist in different phases, like mercury vapor or metal fumes. And as both Alan and Joanne mentioned, there's those odorants, and they are important, that there may not be a toxicity factor, but there is definitely, people can smell things at very low thresholds, some people better than others. And so it's important to understand if you have an odorant as well. Can I have the next slide, please? So as I said, once you identify our contaminants of concern, you start looking at what exposures from a duration of your remedial action. And you, as you heard Joanne talk about, and it'll be obviously discussed later, about the PAM calculator. It's a wonderful thing. It means you don't have to make those spreadsheets and create your own equations. So if you use it correctly, it's a great tool, and I heartily recommend the use of that. Again, to help shine a light on that black box. But there's important things to consider. Acute short-term exposures can be a problem too. We usually look at the longer-term exposure. That's important too. And as we all mentioned a couple of times, is the PM10, which is the National Ambient Air Quality Standard of 150 micrograms per cubic meter. So that's, you can't see it, but it's not visible dust, but it's invisible dust at these low diameters. And that should be important to you in your development of your PAM as well. And then, as I mentioned in the previous slide, is the nuisance odors. How many times a good example, as Alan was mentioning, is manufactured gas plants. There is a distinct odor that of mothballs, if you've heard that, which is basically an indicator of manufactured gas residue. It's people can smell it at orders of magnitude differences. Somebody might not even be bothered by it at all, and others, are extremely sensitive. That may be due to some pre-existing condition, if you have asthma, things like that. So nuisance odors can be a problem, and we really need to not forget about them. May I have the next slide, please? Let's move then to an important critical component of the perimeter air monitoring plan. And this is the conceptual site model. This, I think a lot of people are familiar with conceptual site models. They might think of it as a groundwater model and very complex mathematically how the compounds move. Again, but here we're really talking about the potential for airborne emissions and subsequent exposure. So how are they going to impact those receptors? And that's important too. Again, remember, if you have a community nearby, could be sensitive receptors in there. And those sensitive receptors, like for nursery, the daycare worker where there's children, they're considered sensitive, elderly, and of course hospitals. So it's very important to understand your receptors and their locations. Again, got to know that characteristics of that source material. You don't want any surprises. And the whole thing about PAM is try to make sure as you're planning that you don't get any surprises or you're prepared for those surprises. We all know they happen, but this will take and have you helpful for you to make sure you can deal with them. Understand, is it how that transport, how are they going to get to those people? Are they going to be bound to the soil particulates and be part of that PM10 I mentioned? Or are they going to be volatile and volatilize in the air? And two different ways, and you got to address them both. So it's important that you understand the transport. And again, uniquely to the PAM is that you're really looking at inhalation part, not dermal absorption or ingestion, but inhalation. As for anything, you got to update it. Keep it updated. Don't, take your CSM and, stick it in the drawer and forget about it and go off in your merry way and do your remedial action work plan, execute it, because there's new information that could come along that will be important. So it's going to be a document that's really keeps living and changing. Because if you do that, I can tell you that it can be a very effective communication tool for stakeholders. Be able to show them this plan, that they know what's going to be happening. They understand just taking the uncertainty and the unknowns out of things makes it helpful to understand for the public and be more accepting of what's being done, as if you communicate to them that you're actually there to be protective of human health. May I have the next slide, please? I mentioned the conceptual site model, and just to show you, this is a very primitive one, but it shows that there's a lot of things that can be going on. But what we're really looking for is the vapor and dust emission, which is centralized in this box on this slide. And this is where you're going to have your exposure point, where your receptors may interact with them as it's transported in the air to the receptors. Could I take the next slide, please? The CSM answers really important questions that you should be asking, but I can tell you the community will be asking as well. What are the source materials and emission generating activities? So when the material's in the ground, let's say, it's not necessarily a problem for those individuals living nearby. But once you take that material and start doing something to it, which is important because we've got importance of remedial actions in environmental situations. But what is important is what are activities that could be generating. Joanne mentioned, if you're creating an environment for emissions, you might be doing that by mixing. For example, mixing a fixative stabilization into your soils, for example. And all those things, even though you're going to end up fixing the original problem, you could generate emissions, and it's important to know what those are. Again, it's not just particulates, it's particulates and volatiles. And some chemicals can do both. Some chemicals can be transported on particulate, but they also can be volatile as well. And that probably is a good example of that, as I think of right now, is naphthalene. Naphthalene, because of its physical chemical properties, can adhere to soil and be transported with soil, but also is a semi-volatile and can be in volatile form as well. PCBs is another. Is there another source of the chemicals that you're looking for? I find this to be so important, particularly in our urban areas. We've got a lot of industrial urbanization that's gone on over centuries, and there could be other sources. We've got transportation that could enhance volatiles like vehicle traffic, and they're also there to increase particulate matter as polyaromatic hydrocarbons or PAHs in soot. So it's important to know what's coming onto your site. In other words, upwind and background, and so you can make sure you can understand that you're not going to be adding significantly to what's going off your site. And again, critical to know who those potential receptors are. Again, looking for the susceptible, daycare, hospitals, senior living areas, because those will be the people that might have lower or heightened sensitivity to chemicals. So it's important to understand what populations that you're dealing with in the public. Could I have the next slide, please? I mentioned naphthalene. It's one of my favorite chemicals to talk about, and how important it is to have background and understand your background conditions. New Jersey air toxic benchmarks for naphthalene is 0.03 micrograms per cubic meter, pretty low. But you can see in this red box that a lot of areas exceed that. So particularly in the northeast section of the state. So it's important to know that and be able to accommodate and understand that. So you will know that what you might be contributing versus what the ambient background might be. Could I have the next slide, please? Benzene's another one. It's a common ambient air pollutant, and it's got a very low air toxics benchmark as well, 0.1 microgram per cubic meter. So look at this slide, you can see the majority of the counties in New Jersey have benzene concentrations that exceed that. So if your site is in one of these locations, it's going to behoove you to understand and know what that ambient condition is, so that you're not adding anything to that concentration that might cause harm to the public health. So again, just the importance of background. Taking your background concentration before you start your remediation for at least 3 days, so you understand what those conditions are and are able to deal with them if there's going to be a problem with something like benzene, if that's one of your COCs at your site, or in fact, if something like naphthalene or PAH. It's very important. Could I have a next slide, please? You've heard these terms both from Joanne as well as Alan. And so we're now moving to step 3. We understand what we've got, where it is, but now we need to say, what are our health-based threshold values, or HBTVs? Those HBTVs are based on New Jersey's hierarchy of toxicity factors. They're the same toxicity factors that were used to create the remediation standards. So those are also presented in the appendix of the PAM. And so there is an important piece that is there, that understand that New Jersey establishes those criteria on 1 × 10⁻⁶ risk for carcinogen for any one chemical, or if it's not carcinogen, a hazard quotient of 1 for non-carcinogens. However, the important thing is to remember that Alan had mentioned as well, is that the project is targeting less than 1 year. So if your project is less than 1 year, you're going to be looking at the hazard quotient, or HQ. And if it has a non-carcinogenic value, that's what the HBTV will be based on. As I said, PAM calculator can be used here. It does help shine a light on that black box, and it helps you guide you through and develop what might appear to be pretty mind-numbing threshold values. So you can move on from that after your calculator values. And this is the contaminant that if you have to send out, you can't do a real-time monitoring, but you have to send a contaminant to a lab, and your real-time monitoring it can be compared to the HBTV. So this is where you develop your HBTV. So this is where your data, all your analytical data of air monitoring will be compared to it. Can I have the next slide, please? I don't know about you, but my head kind of spins when I start seeing a lot of acronyms and new terms. And don't be frightened. We're going to get through what the difference is between the HBTV and the response level. And I put it together, this chart, because I did it, first of all for me, to make sure I can understand and communicate what the difference of the HBTV and response levels and the importance of those. As we mentioned, HBTV are those chemical specific. It's the benzene air concentration that it was developed based specifically on your project duration, 8 hours a day, 10 hours a day, and equal to or less than 1 year, as I mentioned. And then again, the toxicity is at 10 to the minus 6 risk if it only has a cancer risk factor, non-cancer hazard quotient of 1. So they're very chemical specific, and this is what you need to make sure that you're not exceeding to protect public health. But what's the response level and what's the differences? Response levels are not chemical specific, but usually a surrogate for that HBTV, or that chemical specific concentrations. For particulates, it could be based on the soil concentration, and specifically like the 95% upper confidence level of your soil. So certainly there's higher and lower concentration, but instead of going for the highest, you can use the 95% UCL of the soil concentration and apply that to your HBTV. For volatiles, you can adjust specific VOCs to total VOCs to measure them in that real-time monitoring with a VOC meter. So at this point in time, you're taking your HBTV times your volatile, or your percent of your volatile organics. Can I have the next slide, please? Again, what are those response levels? They are based on that HBTV, in other words, based on toxicity. There can be adjusted based on soil concentration, like the 95% upper confidence level. And there are other considerations, like you really want to be able to measure full regular time, so you have a good surrogate for what might be occurring with the chemical of your concern. So the surrogates for HBTV, as I mentioned, it could be you can use PM10. You can convert your HBTV to basically a dust value, and certainly it would help you get you some relief for real-time monitoring. It's obvious it's less restrictive than HBTV, but it's an important internal threshold that you can have to make sure you can respond, do something different if you're for your control of dust or volatiles without going over that very important HBTV, which we don't want to exceed, certainly for the project duration. If you created this surrogate and all the assumptions that went into the surrogate for the HBTV, and using that as your response level to react to, you should make sure that you have a chemical specific laboratory sampling that shows that what you're actually measuring in HBTV. So you can show that even though you're less conservative with your response level, but you're chemical-specific laboratory samplings will show that you're on course and with your not to exceed the HBTV. Yeah, the next slide, please. I think we can move on to the next speaker.
Thank you, Deb. We're going to move on to Alan Motter and Amanda Gelfinger to discuss the PAM calculator.
Thank you, Diane. So Alan Motter back again. Won't reintroduce myself, and I'm going to talk to you a little bit about the PAM calculator. Next slide, please. So what is the purpose of the PAM calculator? Why did we develop it? Why should investigators use it? As Dr. Prasadi Deb just went through, sites can contain a myriad of contaminants that require perimeter monitoring, and the HBTVs are going to be based on exposure parameters that are specific to what your remedial action plan is for your site. The response level will also vary from the HBTV based upon the contaminant levels at your site. So the calculations to determine these thresholds can be complicated and can be time consuming. And so we wanted to develop a tool that investigators could use that would make things easier so they could quickly create site-specific HBTVs and response levels. Now, people are always welcome to develop their own calculators or do things outside of that. However, all the parameters that go into calculating HBTV, including toxicity values and exposure assumptions and so forth, should be the same. So this tool hopefully will allow people to calculate these things very easily. Next slide, please. So when you go to the guidance documents website for the CSRR and click on perimeter area, you will get a tab to click on to bring up the calculator. When you do, you will likely see this security warning, because there are a lot of macros that run in the background, and so your computer will probably perceive this as a potential threat. However, we're from the government. You can trust us. Please enable the content in order to allow those macros to run. Next slide, please. Once you open up the calculator and enable the macros, you should see this page. Now, depending on how far you zoom in or zoom out, you may or may not see this entire interface. However, I wanted to show you what the interface looks like, and then we will be going through each component. So on this interface, the majority of the space, the upper left-hand corner, which takes up about 3/4 of the interface, is the calculator itself. And you'll see there are yellow and blue boxes. We'll talk about those in a bit. Directly underneath those are a series of radio buttons. We will talk about each of those in turn and what they do. To the right, you will see the equations that Deb had talked about. And these are the equations that go into calculating both the HBTV and the response level. And finally, at the bottom, on the bottom right-hand corner, are a list of the acronyms that we use and what they mean. Next slide, please. So starting with the calculator itself, you can input site-specific information. So you'll notice that there are blue boxes and yellow boxes. The blue boxes are boxes that you can put information into. The yellow boxes are locked. They are either default values or calculations. So looking at the upper left-hand text box, The first set of blue boxes that you'll fill in is just site-specific information, such as the site name, PI, who did the evaluation, and the date. Moving to the next text box, you see where the green arrows are going there. You will fill in your exposure time and exposure frequency. This will be the number of hours per day you're anticipating doing the work and the number of days that this work is anticipated to take. Again, these values we have predetermined to be between the values of 8 and 12 hours per day, because that's a typical work day. If you need to go outside of those hours, please contact us and we can adjust the calculator. Also, the frequency between 20 and 225 days. As Joanne had mentioned, below 20 working days, this document is not applicable to your site. And if it goes beyond 225 days, we're moving from a subchronic to a chronic exposure. And so the parameters that we'd be looking at will change. And so if you're going longer than 225 working days, which would be basically a year, please contact the department and we can work with you for that. If you do enter values in these areas that are outside the ranges, you will get an error message, and all you have to do is simply re-enter your value. Next slide, please. All right, in that row, the final blue box is the number of contaminants per page that you would like to evaluate. You can evaluate between 1 and 4 contaminants per page. And this is something that we did receive comment on when we issued this calculator in draft. And we had considered increasing the number. However, the lift to do that and the time frame we had to do it, it really wasn't feasible. So it is a comment we will keep for the next iteration of the calculator to look at. However, with the radio buttons down at the bottom that I will go through later, it is fairly easy to produce multiple sheets without having to re-enter all of your information. So you will select the number of contaminants as a drop-down menu, and you can select 1 to 4. Next slide, please. So looking at the radio buttons on the bottom, the first one is reset values, and you can see the red arrow pointing to the blue fields. This is for entering your percent of volatiles in air or your soil concentration for a specific contaminant. I will talk about that more later. But you can enter values in there, and if you decide to change those values, you can simply hit the reset values button and it will reset everything for you. The next button is reset chemicals, and as the red arrow indicates, that is the chemical list. If you hit reset chemicals, it will take all of the chemicals you have listed there and change them all to astaxanthin, which is alphabetically the first chemical on our list. And then finally, there's a reset all button, which is the third button there. And that will reset everything, including all your site-specific information. Next slide, please. This is where you will enter the contaminants of concern. So as the 2 red arrows indicate, there's a field where you'll select your contaminant of concern. When you click in there, you'll get a drop-down menu. And all of the contaminants that are listed in the remediation standards will be there in alphabetical order. So you can simply scroll down, find the chemical that you need, click on it. It will enter that chemical, and it will the calculator will automatically pull up all of the associated chemical properties and toxicity factors associated with that chemical. Next slide, please. Okay, so how to use the calculator continued, using lead and benzene as an example for this particular slide. Before any data is entered into your concentrations and results in red, it will default to the threshold values that are based on the inhalation reference concentration or the inhalation unit risk factor, depending on the contaminant. As Deb said, since it's a subchronic condition, we choose the non-cancer endpoint unless there is no non-cancer endpoint. Then we will choose the cancer endpoint and adjust it from a lifetime to a shorter period of exposure. Once your data is entered, the red threshold associated with your data will change. In this example, we put in 6,000 parts per million for the lead soil concentration. And as Deb had mentioned earlier, we're looking at, say, a 95% UCL for the remediation area, not for the whole site, but for the area that you're remediating. Look at your 95 UCL, use that concentration, because what we're saying is that the soil particles being released during your remediation, on average, will have that value. As you can see, the response level is now significantly higher than the HBTV. So the HBTV is at 0.45 micrograms per cubic meter. However, the response level is at 75 micrograms per cubic meter. So what you will be monitoring for the dust is actually significantly higher than the HBTV, because that dust is not 100% lead. It is, we're assuming, only 6,000 parts per million lead. For benzene, we entered 50%. And again, there's procedures in the guidance document, and I think Erica will be talking about this a little more tomorrow. But there are procedures for determining what percent of your volatiles out there are a particular contaminant. So for this site, we're saying that 50% of our volatiles is benzene. And as you can see, it changes the response level. Because it's 50%, it basically doubles your response level, both for micrograms per cubic meter and parts per billion volume. So you would monitor for the higher concentration of total volatiles. Next slide, please. All right, so if the calculated response level would be above the National Ambient Air Quality Standard, or NAAQS, that Deb has talked about, it will default to the NAAQS of 150 micrograms per cubic meter. And the reason for this is when we had gone through the SAB, they were very insistent that we do not add to or exceed the NAAQS, because that is a health-based value based strictly on particulates and not necessarily a contaminant, but the level at which a particulate will have adverse effects on people's respiration. So if your calculated value is above 150 micrograms per cubic meter, the calculator will automatically put the level at 150. Also, some contaminants such as naphthalene, as David mentioned, may be present as volatiles or particulates. So in this case, we chose naphthalene, and you can see that it gave you a choice for both particulate and volatiles. And we'll give you an HBTV, one HBTV, but a response level for looking at particulates versus volatiles. Erica will get into this a little more tomorrow, but you can, through looking at laboratory data, after a couple of rounds of samples, you can eliminate looking at one pathway or the other if the contaminant is present more significantly as particulate or volatile form. Next slide, please. Please note that some contaminants, such as mercury, naphthalene, and PCBs, will refer you to the user's guide. The user's guide can be found by scrolling down to the bottom and looking at the last radio button, which says Go to User's Guide. It's indicated by the green arrow. When you click on that, it will take you to the user's guide, and Amanda's going to be going through the user's guide in more detail later, so this is just a very quick introduction. Once you get to the user's guide, you will see a table of contents, and in this case, for mercury, it is asking you to go to section 5.2. So when you see the table of contents, response levels, it is section 5. You click on that, it'll take you to section 5. Scroll down to 5.2, look at the information. Once you're there, you can scroll down to the bottom of that section. There will be, as indicated on the bottom of the slide with the green arrow, there will be a tab that says back to table of contents. When you click on that, go back to the table of contents, and there's a button there to return to the calculator. Next slide, please. So once you are finished entering all of your site-specific information, your chemicals, and the percent volatiles in air and soil concentration for those chemicals, you can print out your results. And as indicated with the green arrow at the bottom of the slide, there's a print button. When you click on that, you will get a menu. Please go to the menu where the green arrow indicates Save As. And in this instance, it will save it as a PDF. Please give it a unique name as to not overwrite other sheets that you may have saved. Once you have done that, printed it out, you can then go back to printing out more sheets if you need to. Next slide, please. So if you need to do more sheets, you can simply reset chemicals. It will save all of your site-specific information, the name, PI number, so on and so forth, but also your exposure, time, frequency, and so forth. So then you can go about entering new chemicals and the appropriate concentrations for those. You would then repeat the process to print. Once you are completely finished, you can hit the exit button and it will take you out of the calculator. Okay, next slide, please. Okay, finally, please note that some contaminants, such as acetylnaphthalene, excuse me, stumbling over that, do not currently have appropriate tox values. So although they're included in the contaminant list, the calculator won't be able to produce HBTVs or response levels. So please contact the department if you run into that issue. Also, for PCBs, HBTVs, and response levels, it cannot calculate those because PCBs are a series of congeners. And depending on which congeners you have on your site, they will have different molecular weights. And molecular weight is part of the calculation that goes into this whole process. So for that case with PCBs, please contact the department. And based on the PCBs you have present at your specific site, we can come up with a reasonable molecular weight. We can enter that into the calculator and produce a result for you. Next slide, please. We're going to test your knowledge, so I guess I'll turn it over to Diane.
Hi, everyone. We're on our second poll question. So it's asking a health-based threshold value, HBTV, is contaminant specific, calculated air concentration average over the workday, C, assumed protective of human health for offsite receptors, or D, all the above. I'll give you a minute to answer the question. And the answer is D, all the above. Okay, you go back to it.
All right, and with that, I'm finished for today. Thank you.
Good Good afternoon, everyone. My name is Amanda Gettelfinger, and I am a research scientist in the Bureau of Environmental Evaluation and Risk Assessment. I am going to briefly go over the contents of the PAM Calculator User's Guide that's included with the PAM Calculator, which can be found at the Department Site Remediation Guidance Library. Alan touched on a few things related to the Calculator User's Guide, and I'm going to elaborate a bit more on those topics. Next slide, please. So the department prepared the Calculator User's Guide in order to give investigators instructions on how to run the calculator to develop health-based threshold values and response levels for site-specific contaminants. The User's Guide discusses input parameters, output concentrations, and how to use the calculated concentrations at the site perimeter with real-time monitoring and confirmatory sampling equipment. The contents of the Calculator User's Guide include the following information listed here, and I'm going to expand on these topics in the next few slides. Next slide, please. The first section of our Calculator User's Guide is the Standard Operating Procedures section, which discusses calculator input values like exposure duration, which would be how many days work is anticipated to occur in a calendar year, and workday duration. It also discusses how to produce the calculator output with the functions that exist on the calculator tab. The second section of the User's Guide discusses the calculator outputs being the health-based threshold values and response levels that will be used with confirmatory sampling and real-time monitoring, and why these values are being established for remediation sites. The third section of the User's Guide is homes in on the health-based threshold values and some of the exposure assumptions that are used and embedded into the calculator itself, like reference concentrations for specific contaminants. It also directs investigators to consult with the department if an HBTV cannot be calculated for specific contaminants because inhalation toxicity information isn't available. The fourth section of the user guide lists out two different equations used to develop HBTVs, one using reference concentrations and one using the inhalation unit risk concentrations, and provides definitions for the various input values. Next slide, please. The fifth section of the user's guide focuses on response levels and their importance for use with real-time monitoring equipment. And it discusses how the response levels are based on health-based threshold values, but also account for site-specific soil data to adjust concentrations to be used with real-time monitoring equipment. It also discusses in detail how to determine the percent volatile of total volatiles at the site. And it discusses contaminant-specific exceptions like PCBs and mercury, which Erica is going to go over later on in our training. It discusses the use of ceiling limits at the perimeter for response levels, and how to apply shorter duration confirmatory sampling in situations where exceedances of the response level are occurring at the perimeter real-time monitors. Section 6 of the user's guide discusses how confirmatory sampling is used to ensure that the perimeter response levels and real-time monitoring equipment are being protective of the daily health-based threshold values. It also lists actions to be taken if confirmatory sampling indicates that HBTVs are being exceeded, and to determine why that is occurring. And lastly, Section 7 of the user's guide provides two calculations for determining response levels. It has the equation for determining particulate response levels for semi-volatiles and metals, which would be particulate-bound contaminants, and it has the equation for vapor response levels for contaminants that would be likely to volatilize during remediation. It also defines various equation inputs. Next slide, please. So we're going to start going into some of the user guide functions. As Alan mentioned, there is a Go To User's Guide button at the bottom of the main calculator page that will take you to the user's guide if you click it. Next slide, please. The Go To User's Guide button will initially take you to the user's guide table of contents, which is a summary of what we just discussed. Immediately above the user's guide table of contents is a very abridged set of instructions of how to run the calculator if you just need a quick reminder on how to do so. But if you need additional information or instruction, each of these sections in the table of contents is clickable, and they will each take you to the section that you select. Or if you want, you can just scroll through the user's guide using your mouse. Next to the user's guide table of contents is also the return to calculator button, which will bring you back to the calculation page that Alan was just discussing at length. Next slide, please. And then lastly, there's a back to table of contents button in each section of the user's guide that will take you back to the clickable table of contents that we just talked about. And it also brings you back to that return to calculator button to go back to the calculation page. Next slide, please. And that is it.
So our first question, going back to the beginning, is the greater than 20 working days within a 30-day period sounds confusing. Can we explain that in more detail?
Sure. So typically you don't work on weekends. So we figured, 30 days is basically a calendar month. Of course, it varies. And typically there are 4 weeks within that working month, which would be 20 working days. So what we're saying is that if your work is going to be less than a month, basically 20 working days, or within a calendar month, that this guidance document would not. So hopefully that makes sense. It's really, when we were considering what threshold to use, there were several things that went into account, including where acute and subchronic start to separate, what exposure is, going to be important for offsite exposures and so on and so forth. So hopefully that clears it up a little bit.
Thank you. Is the responsible official who is responsible for this, or is it the LSRP?
Well, the LSRP, assuming it's an LSRP site, the LSRP is going to be responsible for implementing the plan. However, there should be a technician or somebody on site who will be monitoring the equipment and has the authority to make adjustments to the work that's being done when there's an exceedance.
If a soil contaminant concentration is less than the inhalation soil remediation standard, is PAM applicable?
Yes, because the remediation is going to be based on whichever standard is being exceeded. So it doesn't matter whether it's the ingestion dermal, the migration to groundwater, or the inhalation exposure pathway. If you are remediating because a contaminant is present, you have to go through this evaluation.
Is it accurate to say that all site COCs might not be COCs for the PAM plan? For example, you might have a non-VOC, SVOC, mercury contaminant of concern, and these wouldn't need to be covered?
Again, if it's a contaminant of concern at the site, you should do the evaluation, but yes, some contaminants may fall out and not be a concern.
If my COC is benzene and I'm using a portable GC or real-time benzene analyzer at low ppb, can this replace the requirement for a SUMA canister sample?
I think that's dependent on, sorry, Alan, go ahead.
Go ahead, Amanda.
I was going to say it's dependent on whether it's, for a field GC, the answer is yes. If your benzene analyzer is COC specific for benzene, the answer is also yes. For anything that is a real-time, non-chemical specific meter, the answer would be no.
Yeah. The other thing is if your instrument is certified versus not, and I think we'll be talking about that more later between Bruce and Erica.
Does the DEP have a list of odor threshold concentrations that could be used in the PAM?
I'm sorry, could you repeat that?
Does the department have a list of odor threshold concentrations that could be used in PAM?
Odor threshold? No.
Yeah, we don't provide that as part of the calculator or specifically discuss it in the guidance. But if there are questions, I'd recommend you reach out to the department and we can see what odor thresholds are available for you.
I would just add to that odor thresholds vary to individuals, so they can be really widespread. It could be orders of magnitude different between what one individual can smell on another. So odor thresholds are a good indicator that you might have an issue, but to be specific on that threshold wouldn't help.
So the calculator allows you to evaluate less than 4 contaminants per page, but does that mean that this combines or integrates them in any way?
No, each contaminant is evaluated on its own merits. So Erica, and then with the case study, Amanda will be talking more about that tomorrow, and what contaminants will drive, the investigation.
For Alan, is the exposure frequency based on cumulative consecutive days or just total days for the project duration?
Total days.
Easy. Is monitoring still required for activities under the exposure time or frequency levels? And we already discussed what the minimum for the 30 days was.
Right, but if you have, a situation where you're directly adjacent to a daycare or a nursing home or something of that nature, and you're doing something that is below the minimum, you probably still want to, monitor that. It's just, like I said, we try to reach a reasonable level that we wouldn't be making you do this for every site.
Is the soil concentration to be used in the calculator necessarily the maximum on-site contaminant concentration, or is it only the highest concentration of material that will be mobilized during the remedial action?
Okay, generally what we're looking at is the 95% UCL within the area that's being remediated. So we want to have, an idea, like some of the particulates may be higher in concentration, others might be lower, but what's that median going to be, and base it on that, again, for the remediation area. So if you're only remediating 1 acre on a 100-acre site, don't use all the data from the entire site, just from that area that's being remediated.
If remediation lasts more than a year, can the calculator be used?
At this point, you're moving from subchronic into chronic, and so some of the assumptions that go into the calculator would change. So if it's going to be more than a year, I would say contact the department, and we can probably modify the calculator for those conditions.
Thank you. It was mentioned that you would use the 95% UCL of a contaminant of concern for the concentration. How do you select the initial list of contaminants of concern? If a COPEC exceeds a particular level, if so, what is the level?
It's based on the remediation standards. So if you're exceeding remediation standards, you should evaluate it. And again, some of those contaminants may fall out. Like if you have, one hit of, say, benzoate pyrene, and you're doing your remediation for lead, which is throughout the whole site, you're probably not going to evaluate benzoate pyrene, but, at least acknowledge that it's there and that you looked at it.
Is the reference data in the calculators updated when there are changes?
So will we be updating the calculator? Sure. If toxicity values change and so forth, we will be making changes, and any changes we make would go out on a listserv.
One last question. Could there be different COCs for the PAM as opposed to the site? For example, you're remediating toluene and xylene in the soil, the excavation, because they are above the soil remediation standards, but benzene is present in the soil, but below the the standards and not considered a site contaminant? Should benzene be considered a driver for PAM decisions?
I would say if you have something present and you think it could be a concern, evaluate it and see which contaminants are actually going to drive the remediation or the not the remediation but the PAM plan.
Alan.
Okay. Thank you, everyone, and thank you, Lynn. So it's currently 2:40, so we're going to take about a 10-minute break. So we'll be back here at 2:50. Thank you.
All right, everyone, it is 2:50, so we're going to come back from the break. Up next, we have Bruce Groves to talk about PAM steps 4 and 5. So Bruce, whenever you're ready.
Good afternoon, everyone. My name is Bruce Groves. I've been in the exposure assessment business, air monitoring for quite a few years. I started working for OSHA as an industrial hygienist back in the 70s. And so I got involved with the whole issue of dose and response and everything that Dr. Prasadi was, or Dan, what she called, talked about. I listened to Alan talk about 1984 and had Steve Job in the MAC. While he was in college, I was standing on PJP landfill, which, if you all remember, was a landfill underneath the Pulaski Skyway, which was burning. And products of combustion were kind of enveloping the Pulaski Skyway. And one of the things that I remember as I was looking and dealing with exposure assessments, mostly during the remediation of that site, is what the heck is in the air that's going up towards the perimeter, in this case, to going on the Pulaski Skyway. And we've come a long way since then. So when I was asked to join this committee, I remember I was given the original guidance document that Alan referred to, and I also read the SAB, the Scientific Advisory Board's comments, and I said, wow, these are restrictive. It was heavy on analytical sampling, supplemented by real-time monitoring. And one of the big challenges when we started this was to flip that and to say, look, we don't want to lead with conducting extensive analytical sampling for air. We want to lead, if we can, with real-time instrumentation to try to get some sort of way to get some understanding of what is actually coming off the site and corroborate that with some confirmatory sampling, which would be a fairly robust analytical sampling setup to support what our assumptions are on how well the real-time instruments are working. And that actually is what happened. So we have this document, the 7 steps, and I got to have everybody remember the whole purpose of this guidance document is to, once you fit into the requirement of developing a perimeter air monitoring program, that you have to develop a perimeter air monitoring plan. And so these steps 1, 2, and 3, which Deb Parsati talked about, is kind of setting up the aspect of first chemicals concern, what are the chemicals of interest, the second being what is the conceptual site model. And from my experience, this is something that a lot of people don't put a lot of time into, and this document requires a much more investment of time and effort to really put a fairly robust conceptual site model, and Deb did a nice job of explaining all the intricacies of that. And the third being establishing these health-based threshold values and response levels, which gets me into the 4th step. And why don't you change the slide, please? Is to identify the monitoring methods and technologies and what is the monitoring strategy. So this slide, we basically are saying if we know what we're dealing with regards to the chemicals of concern, we know what kind of targets we're trying to meet with regards to keeping below a health-based risk threshold. How are we going to monitor this so we have a pretty good understanding of what sort of emissions and what sort of contaminant transport is going to be established with this site. So the first aspect is the first bullet here is our qualitative assessment. What kind of measurements do we need to be made? And what are our data quality objectives? We're going to go into some detail on the quality assurance program, but basically the DQOs that we want to look at, is this a site that where we have a number of very vulnerable off-site receptors, or is it a rural site where, frankly, there's enough buffer in the area, we don't have as much a concern with human exposure off-site. We're also looking at the toxicity of the type of chemicals of concern we have. So the DQOs are important on the numbers of samples, the number of sampling stations we have to put together, the types of measurements, the type of equipment, how quickly do we need this information, and so on. The second bullet here is we need, and this is what we push this whole switch into relying first on real-time data, is we want to be able to control emissions before they become a problem. So real-time data does this. Joanne actually added one thing that I think is very important, is that this real-time data also does a great job of measuring the effectiveness of the controls. So if you're deciding to keep dust down, for example, and you are looking at particulate levels, you want to make sure that your real-time monitoring is effectively giving you the feedback that this control mechanism is actually working as you have designed. The third bullet here on the strategy is you want to make sure when you start dealing with this real-time data and the response levels, and I think everybody, you may not totally understand the difference between response levels and HBTVs, but I think that now when you're dealing with what are the response levels, the levels that our real-time monitors are going to be used in order to take action, you want to make sure that these levels are adequate and that they're doing what they're supposed to be doing to keep the health-based threshold value levels below the associated acceptable limits. And the last one is documentation. Alan mentioned the importance of the reports at the end of the remedial action, and so the PAM program is a big part of that to make sure that whatever was designed, that it was implemented correctly, and you can say from a documentation standpoint, it did protect the public. Next slide, please. So there are a number of items here that we're going to deal with here that gets involved with different monitoring methods. The first is remedial technology selected. We'll talk a little bit about that on the next slide. Your source receptor relationship. What type of COCs are identified? Are they all inorganic, such as lead and hexavalent chromium or things like this? Or are we dealing with volatiles or semi-volatiles? The fourth being the established HBTVs for these COCs. And the last one dealing with, do we have any specific real-time technology that can be utilized to measure specifically these COCs, okay, to document HBT exceedances. The best case in a real-time instrument is that if you have a real-time instrument that can measure the contaminant of concern and it is accepted from a technology standpoint, then that can be utilized to not just have response levels, but also to be utilized in determining whether or not you're exceeding or you're being below the HBTV. Next slide. So when you're dealing with monitoring, the type of remedial technologies selected. So you have 4 pictures here. So everybody use their imagination a little bit here. So you could have in the upper picture a in situ stabilization where they're actually excavating a little bit. They're putting concrete or some sort of material subsurface. The actual emissions levels in that case may be not so great because they're underground, or in the case that might be generating heat if they're mixing materials, whatever the technologies. That's part of your conceptual site model to say, look, we're utilizing this type of technology. We know these emissions. It could be particulates. It could be volatiles associated. If you look at the slide on the upper right-hand corner, here's an excavation. I recall NGP sites, which is where I really got involved with permanent monitoring back in the 80s and 90s, and going forward. We exposed, when we started excavating in MGP sites, we exposed volatiles that were being controlled by the soil. And once you excavated the soil, you had a release. You had an emission release. So if that's the case, then that type of technology and the associated controls, so remediation technology, would drive a lot of what you're going to do in a perimeter air monitoring program. The bottom slide is demolition. You might have a demolition involved with building materials that may not necessarily be part of your remediation, may be supplementary, but these all have to be addressed as part of your strategy. Next slide, please. You have the source-receptor relationship, and this is very important. And there was a comment I know that Joanne made about we're lucky to be living in New Jersey for a lot of reasons. But the one thing about New Jersey, it's the most densely populated state in the country. And being so, you're not going to be too far from various types of receptors that could occur. The landfill that's on the upper left-hand corner, this happens to be in a residential area, very, very nice houses are in that woods that surround the landfill. This was a landfill that was closed in the 70s, and then it was laid dormant for many years, and as a result of that, people built houses. A lot of people in those houses never even knew the landfill existed until it got reopened. This was post Sandy, and so you had hydrogen sulfide being produced by a reopening of this landfill to put a solar farm on this. And the construction debris that was brought in, a lot of sheetrock and things like this, produced these reduced sulfur compounds. So you had a situation where there was odors, and you had a situation that you had direct exposures to people in the woods here. You can see the heavy populated area of the town above the landfill. So when you're starting to look at your monitoring strategy, you want to say, where am I going to put the monitoring stations? How are we going to make sure that the identified receptors are being protected? You look at the bottom right-hand corner. This is an excavation in an area of contaminated soil. Happens to be next to a hospital. So you've got an issue where receptors are obviously of concern. You're not only dealing with receptors of people and houses, but you have the HVAC system of the hospital that you want to make sure that whatever emissions are being generated here, that the monitoring strategy take into consideration of the tightness of the site and the location, so you can say from a high degree of confidence that your emissions are going to be controlled enough to be below the HPTVs. Next slide, please. The other items that we talked about here, the list of COCs, I think we talked at length about the various types of COCs. I know one comment was made, you have to address all COCs. You know, if you have a soil sample and you have 16 different chemicals, you can obviously put a priority together and determine which chemicals of concern would be of the greatest concentration and which chemicals concern would have the lowest toxicity limits. It doesn't mean you don't have to look at each one and determine which ones would be of concern, run them through the calculator. But you can take a list of many different types of chemicals and really focus on the ones that are of concern. And this has to be documented in your perimeter and monitoring program, your plan, I should say. But I think it's important to recognize that there is some sort of qualitative assessment that can be done on trying to target the chemicals of concern of most importance. And then when you start looking at which HBTVs, I put together a number of chemicals of concern which are typical. I wouldn't say they're typical, but there are a lot of sites where benzene or chlorinated solvents, trichloroethylene being a driver, hexavalent chromium, lead, these are ones where you can say and identify as an example, we're going to focus on benzene, and if we can document that our volatiles for benzene are going to be below the HBTV exposure, then the other chemicals that are associated with the site, the other volatiles, for example, are going to be well below the HBTV. So next slide, please. Getting back to your monitoring strategy, you want to identify the right real-time instruments for these specific chemicals of concern. Deb Barsati mentioned the term surrogate, and surrogate is a much-used term in the air monitoring business, which basically said, and lead, let's use lead as an example. If you have lead in the soil, there is no real good, effective, reasonably efficient, I should say, or cost-effective instrument in the field that can measure lead. But you can measure particulates. So you have on the upper right-hand corner a monitor. This happens to be a TSI dust track that could measure particulate levels. And so part of your response level calculation that is being driven in the calculator is you're going to determine that if your total particulate levels are below a certain number, then your model can say, within 95% upper confidence limit, that your lead levels are going to be below or well below the HBTV. So you're not monitoring for lead, but you're monitoring for particulates that you assume are going to have lead in it. And that's your primary strategy to make sure that this potential exposure is going to be controlled. You have on the lower left-hand corner, this is a gold film. It's either a hydrogen sulfide monitor or a mercury monitor. They kind of look the same. But here's a good example where you have an instrument that's really more specific on a specific contaminant. It's hydrogen sulfide, and it's very difficult to measure analytically and collect and sample for hydrogen sulfide. So there's a heavy reliance in this case on using the real-time instrument as the means to not just determine real time if there's a response level that you have to control, but also to document that you're going to be below established HBTVs. You can see the same thing for mercury. Mercury is, again, a little less difficult to measure analytically, but you can also use an instrument like this to determine whether or not you're going to be below specific HBTVs. You have a gas chromatograph in the upper right left-hand corner. Amanda mentioned about the specificity of the GC. If the GC is specific to benzene, for example, or chlorinated solvents, trichloroethylene, it's possible to use this as a screening method, is to look for response levels, but also use this as a means to specifically measure that specific chemical of concern. The bottom right-hand corner is a photoionization detector. It's a mini ray. These are fairly common. The beauty of these instruments is that technology is changing all the time. They're becoming more robust, they're becoming less expensive, they're becoming more precise in a lot of the work of the data that they're getting. The mini ray, for example, is a good instrument to look for from total volatiles, again, as a surrogate. Chemicals that are based on their ionization potential, but it won't be used necessarily to document whether or not you exceed the health-based threshold value. So here are some examples, and there are quite a few other types of real-time instruments out there, but these are ones that you typically will see in this type of work. Next slide, please. So when you select the air monitoring methods, you basically have two different types. You have the handheld real-time monitoring, and then you have the actual fixed or stationary real-time monitoring. And so I'm going to talk a little bit about those two in a minute here. The third item is meteorological monitoring. So go to the next slide, please. So when you look at handheld monitoring, one of the things I think it's important to recognize in this plan and is that the program that, the guidance document that we put together, we did talk about the importance of handheld monitoring. They do play a value. They're very good in looking at hotspots, but they are recommended strongly that these are supplementary to more station or stationary or mobile type stations for perimeter monitoring, which I'm going to talk about next. They do have their value. The one on the upper left-hand corner is another particulate monitor, handheld. You have a handheld meteorological monitor. That's the upper right-hand corner. It's a kind of little sharp little instrument that can show at least wind speed and direction and some other basic humidity, temperature, things like that. We have another mini ray on the bottom right-hand corner, and the mercury hydrogen sulfide monitor, bottom left-hand corner. You can see these are handheld. Some of these are put in a box and put as stations. Next slide, please. Which gets us into the issue of establishing either stationary or mobile. The difference really between stationary and mobile is in our example, for example, of the landfill that I said a few slides ago, we had a pretty good situation where we understood where the receptors, the sensitive receptors were, and we could put more stationary stations. And if you look at the far right corner, these are kind of a stationary. It can be moved, but it's not really designed to be moved daily. We could also utilize power. If you have a more stationary issue, then if you can find AC power, that solves a lot of problems. Doesn't mean they're limited to that, but the other thing you recognize is these are laboratory grade instruments that they put in boxes, and the least, as little as handling as possible makes them work much better. So if you don't have to move meteorological monitor stations very often, or if you don't have to move a lot of this equipment, and you don't need to handle it a lot, it tends to be much more robust. Doesn't mean that moving it makes them fall apart. It just knows from my experience, it likes to stay put if possible. The far left is more of a mobile station. You have your orange box on a tripod. You can set it up during the day because you may have remediation occurring that day, or you have a hotspot that's occurring that you need to set something up on a temporary basis, a couple of days, things like this. Both of these stations, and the one in the middle you can see is another permanent type or semi-permanent, I should say, stationary monitor. They all have their values, and these are the ones that we prefer to have established on a perimeter monitoring program over just saying we're going to have handheld data or handheld instruments being used. The handheld instruments can supplement the data of the stations. Next slide, please. Meteorological sampling. You have here your classic upper left-hand corner, an EPA 10-meter station, which EPA, when you start dealing with atmospheric type impacts, this is something that they require. I came out of from the exposure assessment business. I didn't come from the meteorological atmospheric toxic area. I came out from the ground up. Okay, so there's a lot of things that occur in the first 6 feet of a site, and there's a lot of air impacts. You have air is not just linear across a site. You have buildings. You've got in a case of urban settings, you got streets. You got things that the wind doesn't necessarily move predictably left to right or up and down, but it can circle, it can move around, it can change direction. So I'm a true believer to use meteorological monitoring, which is becoming more reliable, smaller, cheaper, and can be used on just setting up a station. This is not a 10-meter station, the one in the upper right-hand corner. This is a field station that goes about 6-7 feet in the air. You have these little, on the bottom left-hand corner, these full weather stations. These are solid-state stations. You don't have the cup that turns around in the typical anemometer. And they can be used very nicely on various stations to show that if you're collecting real-time data, that you can associate the data that's being collected to the specific wind direction that's occurring. So if you have, for example, sensitive receptors, you want to see that you happen to be moving from a contaminant transport, and the contaminant's moving towards those sensitive receptors. Or if you have a background issue where there's an off-site impact, which has happened quite often, where you have an industrial operation, you may have some sort of auto shop, or whatever it happens to be that happens to be the neighbor of your remediation. You can actually look at sampling data and assign wind direction to that sampling data to document that the numbers that you're picking up are not associated with your remediation, but may be associated with that, with some sort of off-site background source. I did talk a little bit about the handheld one before, so I don't need to go into that. Next slide, please.
All right, everyone, it's time for another poll question. So this is poll number 3. The question is, a real-time monitor is equipment that A, can measure total concentration for a group of contaminants, B, can be handheld or fixed, C, can display instantaneous concentration readings, or D, all of the above. You'll have about a minute to answer this question. Remember to answer it in the poll, not in the chat or the question box. And just a reminder that the agenda is available in the handouts drop down on your screen in GoToWebinar. And also just a reminder that there will be another training next month for the field sampling procedures manual updates. So keep an eye out for information coming soon on how to register for that training. It will be on February 29th. All right, the last 10% or so of you who haven't voted, make sure you vote so you can count your attendance today for credits if you need them. All right, next slide, please. The answer is D, all of the above. Back to you, Bruce.
So I'm halfway through my presentation, so it's a good time for everybody to kind of sit up straight, stretch a little bit, and as scintillating as the next one's going to be, it just gives us a little bit of more blood flowing to our brain here. So let's continue. I mentioned earlier that the SAB was very strong on analytical methods, and we've kind of made sure that we've kind of flipped that a little bit. But we don't want to underemphasize the importance of confirmatory sampling. And so I think it's critical that as part of your PAM, that you want to make sure that all the assumptions you've made in establishing response levels with your real-time instruments, that you have a good way of documenting that this is working as designed. And so the first thing as part of your plan is to put together a methodology on how you're going to verify that these assumptions are correct, and what is your real-time monitoring program, and what kind of analytical measurements are you going to use. Okay, GO15 for volatiles as an example, or just for analytical sample, whatever analytical method you have. One critical thing is these HBTVs, these threshold values are fairly low in many cases. So it's very important to get a method detection limit, a minimum detection limit, sensitivity, so you know that these analytical methods are going to see concentrations of whatever COC you have that is below the HBTV. As a rule of thumb, I like an order of magnitude. So if an HBTV happens to be a part per million, I'd like it to be 0.1 part per million as the minimum detection limit, or 100 parts per billion, or whatever unit you want to use. But that's just a good rule of thumb. The other important thing when you start looking at the confirmatory aspect is what laboratory method can you use. And I do got to say that I was really, really pleased working with the department and the team here, because we had some open discussions and a lot of different things. I came out of the world of ocean methods, NIOSH methods. I looked at some of the EPA TO methods and utilized those. I utilized methods that were modified methods of all those things, and of course the other methods, CARB methods, which is California. So I always looked at a whole group of different methodologies, or different analytical methods. And my goal was to try to get a method that was easy to sample, easy to use, so you didn't need a real complicated sampling train. And look at cost. If cost was something, is there a way to measure something, an approved method, and to do it without spending lots and lots of money? And a good example would be hexavalent chromium in Ocean Method 215, which was a reasonably easy method to sample, and an easy method to, you didn't have to freeze the sample and things like this, and it was reasonable from a cost standpoint, versus the EPA's CARB method, or the California CARB method, which was very complicated. You had to make sure that the methods were frozen, and it was expensive. And I didn't think it was as good. So we spent a lot of time making sure that our method was approved, which gets us into the next aspect, is NJP DEP certification. The DEP would like to see, as part of this guidance document, that the method you use, the air monitoring method used, is a certified method by the department. And for a lot of methods, this is a slam dunk. It's very easy to look it up and determine, are you using a certified method, like the OSHA 215 I talked about. But there's a lot of air monitoring methods that haven't been certified by the DEP. They've spent a lot of time certifying for soil and water and things like this. But the air methods, there's a lot of methods that are really being introduced at this time. And so it's important that you first look to see if you had a certified method. If you don't have a certified method, and it's something that you want to use on a longer term basis, the guidance document is pushing you, and it's recommended, highly recommended, to get that certified and to move in that direction. There are exceptions, and if there are exceptions, this is where you can contact the department. Next slide. We have to have methods. I talked about the minimum detectable limits. We talked about the sensitivity. You want to make sure that these methods are directly comparable to your project HBTVs. The frequency is another thing that has to be documented in your perimeter air monitoring program. How often do you have to take analytical samples? The plan itself, or the guidance document itself, as an example, recommends that when you first start work, they say, why don't you do 3 days initially? It's kind of arbitrary, but it's a good rule of thumb, where you have your project, you're starting, you take samples, you get to see real results compared to your response levels. And then after that, you want to establish periodic sampling. Do you take it every week? You know, is that the frequency? As data actually it starts coming back, you may see that your response levels are tremendously conservative, and you may end up saying, well, we don't have to do it weekly. Maybe we'll do it every other week, or it might be the flip. You may have to do it more frequently. But this is a big part of your frequency of when you do confirmatory sampling. Obviously, there are changes. If your site, hotspots is a good example. If you have a site that heavy contamination of arsenic, for example, but it's only located in a kind of a one area, well, then you're going to want to make sure your perimeter air monitoring program monitors dust and specifically for that, and you may have to increase your frequency or the types of confirmatory samples specific for that COC. And the third bullet is changing remediation methods. Obviously, if you're excavating or if you're doing anything that could create emissions, and if you change that, or if you change it where your emissions may become greater, you got to modify your frequency of confirmatory sample. The last item is what I talked about is you do have the ability to change the frequency, the type, and of confirmatory sample based on the data as part of your project. You may be conservative in the beginning to do it more frequently, but as you start getting more experience, you can maybe make modifications that make sense for the project. Next slide. The program, I should say, the guidance document does specifically talk about these three areas. I was kind of smiling at Deb Barsati when she said one of her favorite chemicals is naphthalene. I was thinking, like, what is my favorite chemical? Maybe everybody should have a couple favorite chemicals, but I totally get it. Naphthalene is a very fascinating such, but we want to address these specific items. I'm not going to get in any detail here, but since this is an introduction to a lot of you to the guidance document, note that if you have a mercury site or you got PCBs, and PCBs, as we know, is not one chemical. There are different types of chlorinated biphenyls in that group, and some of them have more toxicity concerns than others. So just address those specific areas and go look and read the guidance document. Next slide. So this is the step 5. Now we're going to look for locations and schedule. How often do you sample, and where do you put these locations? So what are the considerations? So we covered a lot of this in starting to look at receptors and so on. So let's go through this a little bit. What are our considerations? Some of it's practical, is that you want to make sure you can conduct air monitoring and sampling and where it's going to occur. We'll talk about some of the aspects of that, some of the practical aspects. How often? Sample collection can also not just be confirmatory sample on a regular basis, but also can be if you have an exceedance, if you have a spike in your real-time monitoring, you may have a procedure where you're going to actually take some samples. How are you going to collect the data? You're collecting the data, hopefully not manually, but in some sort of database that actually can provide. When Alan looked at the Macintosh and the graphical user interface, we have come a long way. That we can provide data in a kind of a visual graphical interface, either on your phone or various computers, and how do you store it, and any type of specialized monitoring equipment. We use radiation. This guidance document doesn't talk about noise, for example. Doesn't mention odor. But you may end up having other specialized monitoring that might not be part of the guidance document, but also be part of the needs and collecting things that are important for meeting the goals of the project. Next slide, please. So more types of sampling and monitoring locations here. We have mentioned, I think, the fixed versus the air sampling monitoring locations, fixed versus monitoring. We mentioned that previously. You want to address what sort of collection at each location. So if you have 10 different air sampling stations, when do you actually collect samples at these various stations? Sometimes you want to look at upwind, downwind type situations, and it's never always that easy because wind doesn't cooperate and necessarily go consistently in one direction. But you can do the best you can, and at least have a strategy on how often you're going to collect the air samples, and how often you're going to have monitoring in certain locations. The air monitoring and sampling specifications. You start looking at the specifications, and I'm going to mention, I'll go in detail on that in a minute. Meteorological data, different procedures, and some background sampling. Okay, next slide, please. Locations. Here we have another landfill. If you're going to start looking at locations, you may end up having, in this case, if this was an active landfill and you have a remediation going on, you may have to put locations for air sampling to protect the workers that are not associated with the remediation. And that often gets complicated because we've done work on active work sites, and though this is more of a public health risk initiative in many cases, you've got on-site workers, again, not associated with the remediation, to make sure we kind of classify them as the public, different type of public maybe. Here you often have, obviously, the contact with the location of either commercial or residential or other types of sensitive receptors, and make sure they're covered. There's also a practical aspect of locations. Okay, if you can get an area that's protected from vehicle traffic, protected from potential vandalism, you may have to put big fences around. We've done this. We put fences around stations, or if you have access to power. If there's no other considerations about location, sometimes you take a practical approach. This is the best place in being able to, for the ease of locations. Also to give you a little access. Sometimes you want set of locations where you have access so you can actually get to the station itself and not necessarily be at risk from a safety standpoint if you put it in a different area. The bottom slide that we talked, you can see this is the demolition. You have residential neighborhoods. It's a much more complicated thing because if the site is being torn apart, where do you put your station so it can be accessible to the person that's actually looking at the station? But these are all things that have to be addressed. Next slide. We talked about fixed and mobile. I think I gave plenty of detail on the last slide of when you try to make decisions about making sure that you have a more fixed station that is really out of the way of any sort of activity that could hurt it or damage the equipment. Next slide, please. Frequency. This is a Suma canister, TO15. This just give you an example. This is a Suma canisters that can be taken as a grab sample, so it basically represents minutes of samples. Or you can put a restrictive orifice and turn it on. It could be an 8-hour sample or a 4-hour sample. So these are all have to be specified as part of your confirmatory sampling and details on how frequently are you going to monitor something and what is the methodology. Next slide. Specifications. When you start looking at integrating data of multiple stations, this is where the technology has been out for quite a while, but it's, in the case of these fixed stations and mobile stations, they tend to all be connected, either wireless technology. Today it's mostly cellular, if not all cellular technology. The old days it used to be kind of line of sight, kind of radio frequency technology that they're behind us, thank you, good goodness. But these can all be collected. The data can be presented, and this, if you look at the left-hand corner, bottom left-hand corner, this is an example of a phone where the phone data can be seen, alerts can be sent to the person. I agree with Joanne that you should have dedicated monitoring technicians, but these dedicated monitoring technicians or people who are dedicated do not necessarily need to be specific. They can have also collateral duty, so they can be supported by off-site people because this data can be home run back to an area where somebody can respond to problems that occur. So that can be managed in many different ways, but I think it's important to recognize that the guidance document is really recommending these fixed and mobile stations that are using the wireless integrated technology. Next slide. We talked about the ancillary meteorological data, and I don't know if there's much more that I need to talk about other than it's important to get some real-time data. A lot of sites have used the commercially available data, AccuWeather, for example, or if there's a site that's located nearby that has a meteorological station. I'm a true believer that on-site weather, on-site wind speed and direction data is critical in order to really understand contaminant transport of the site. And next slide. What are some of the determining the needs of various additional monitoring methods and background samples? Some of the additional monitoring procedures, we talked about odor, and odor is it's a nuisance. There's no question. And I spent a lot of my career explaining to people that it might smell bad, but it's not necessarily a a toxic or a health risk. I'll give a good example. Ethylene glycol, remediation at an airport where there was de-icing procedures for many, many years. The ground was saturated with ethylene glycol, and it smells like radiator fluid. And it doesn't have it has a very fairly low odor threshold. From a toxicity standpoint, it's got a very reasonably high HBTV, or basically wouldn't even, it's really not a toxic issue, but it's important to try to measure and try to determine what we can do with regards to determining what the concentrations are, especially when you're dealing with off-site impacts. And it's not easy. There are not a lot of things that are out there, but if you can determine and identify some sort of means to quantify the odor thresholds. Hydrogen sulfide was a good example where, the odor threshold lists say that hydrogen sulfide odor threshold is somewhere around 30 parts per billion. And whether or not that's 30 parts per billion for everybody, that's highly doubtful. Some people can smell it lower, most people might be able to smell it higher, but at least you understand what the odor is, and if you measure the concentration, you can get some understanding that if the levels are below 30 parts per million, that you're not going to have an odor issue. But, and background sampling, kind of to finalize things here, we went back and forth as the committee about how to handle the data from background sampling. I'm not sure that I know that we don't eliminate the issue of background sampling. A good example would be mercury and chloralkali remediation. Like there's certain areas where the background mercury levels exceed the HBTV. And so how do you handle remediation where you're dealing with mercury when the background levels are above the HBTV? Deb Barsati actually mentioned naphthalene. And so this is something I think is very important. What I recommend is make sure you know what the background levels are. And when you establish your response levels, make sure you recognize that you're looking at an incremental increase from the background. And if you are not sure what to do, this is a good opportunity to contact. Next slide. This slide looks familiar. Thank you very much.
Okay, we're going to now take questions. So first one is for if, for instance, you're implementing a remediation using electrical resistivity heating, and the system includes a soil vapor collection system to capture the volatile compounds, do you need to still implement a PAM?
I can answer. One minute. I don't want to speak for the department, but why not? I think it's important when you look at a perimeter air monitoring plan that when you have a remediation technology, and we've had experience with this in certain ponds and collecting benzene, that you do have to go through the process of identifying the COC, doing a conceptual site model, looking at the HBTVs. And if you get to that point where you recognize that there really is not an emission source that would be created, then you still have to put together a process, a PAM, but it may not necessarily be requiring even sampling sometimes. But go ahead, Alan, do you want to comment a little further?
Yeah, so if you have electrical heat, resistivity heating, or air sparging or something of that nature, if there's a potential for the volatiles to not be captured and become an off-site excursion, then yes, you should absolutely be looking at a PAM plan for that. Erica, Amanda, you want to jump in?
Yeah, also the use of soil vapor extraction, that also may trigger air permitting requirements and controls that may be needed. So that would be part of your evaluation.
Okay. Next is, does the guidance require that a meteorological station be set up as part of the PAM, or can local weather station info be acceptable for use? / also can be researched from a station on the internet.
A site-specific met station should be present because we're looking at those local meteorological conditions at breathing level, whereas met stations that you might get from a regional area are going to be up much higher, as Bruce pointed to in his discussion earlier, and they're not going to be representative of the site where remediation is being performed.
Okay.
And the beauty is, it's not that difficult necessarily to put together a site meteorological station, not like the old days where, there was a much more costly, more complicated area. There's some good technology, which I pointed out.
Okay, and to follow up, is there a requirement for 24-hour monitoring?
There is not a requirement. The way the guidance is written is monitoring should be occurring when remedial actions are occurring. However, if you're having exceedances of your response levels or your HBTVs, or there's reasons to believe that 24-hour monitoring is necessary and best management practices are not enough to keep airborne emissions at bay, then yes, in those situations, 24-hour monitoring should be conducted. Or you may choose in the beginning of your remedial activities to conduct 24-hour monitoring, or even a couple days before you start, to have an idea of background concentrations and what you're seeing when remediation is not underway.
Okay, thank you. Do you have a list of approved particulate matter monitoring devices and configurations, or criteria for selecting such device?
We do not, and the department can't endorse any one device.
Yeah, and to piggyback off of that, there are a very wide range of devices that exist on the market, and ultimately, I think the selection of real-time monitoring equipment for dust is going to be specific to your site and the conditions that you're seeing at your site and the contaminants as well. With that said, you can work with various external consultants to find the right piece of equipment that works best for you.
One comment I could say, which kind of piggybacks on the two answers that Eric and Alan gave, is that the guidance document, and this is, I think, something that kudos to the committee. The guidance document is really designed to do qualitative evaluations, conceptual site model, making decisions. It is not a one size fits all requirement here. So do you have to do 24-hour sampling? Do you need a MET station? Do you need this? This is all based on your conceptual site model and whether or not you can control the emissions and keep the levels below the HPTVs. And that gives the LSRP and the various experts involved some flexibility in making sure you're putting the right program, right plan together for that specific item. So I think that's a plus.
Okay, thank you. So are there specific NJDP personnel to contact regarding development of HBTVs and response levels?
The answer to that is yes, and at least on my screen or on either side of me, Erica and Amanda will be they actually are the contacts. They're already up on the contact list. And I'll be talking more about that at the end of the day tomorrow.
Okay, thank you. Is molecular weight slash DEP consultation needed if PCBs are determined to be only a particulate concern and not a volatile concern?
It's okay if we want to answer this.
Yeah, I think we're going to have to respond to that. I honestly don't know the answer off the top of my head.
Okay. Okay, this is next one. Is PAM required for any site where excavation activities are being conducted less than 30 days?
Less than 20 days in a 30-day period?
It just said less than 30 days, but okay. Yep.
Let's assume.
Oh. Okay.
Again, I think Joanne stated that the department at its discretion can require, at least for those sites where we have direct oversight, that there's maybe extenuating circumstances. I would also say that the LSRP should look at their site and determine, if there is cause. They should look at permanent error monitoring, even if it's less than the 20 working days within a 30-day period, because, as I stated earlier, if you have a site where you have free product and you're adjacent to a daycare or something like that, I think you're probably going to want to monitor, even if it's going to take you less than 20 working days.
Okay. What happens / are there any penalties if response levels are exceeded for the daily value from the calculator?
So I'll go over this tomorrow a little bit in the training, but with a response level exceedance, there are actions that the investigator should take, such as checking your equipment, checking are there sources of emissions. Is it due to remedial operations? Could it be an off-site source of emissions? And that evaluation and the findings of that evaluation should be documented and submitted in your final PAM report, which would be part of your remedial action report.
But I think, ultimately, if you exceeded the HBTV over the course, the average concentration over the course of the day, there aren't any penalties per se. It's a matter of documenting it, and what we're really trying to look at here is to show that you've been protective of human health, over the course of the project. Hopefully it doesn't come down to a litigation or something of that nature between residents and the site, but if it does, you have your documentation that you were being protective.
Okay. Can there be some clarification as to when confirmatory sampling indicated in the guidance as example as TO15 for volatiles is necessary, and at what frequency that would be required?
I think if you feeding on what Erica said with regards to 24 or 8-hour sampling, it's more of a qualitative assessment. We did put some minimum levels of frequency for confirmatory samples in the document sometimes to kind of pick things off, but then it's really depending on the data that's being collected on what type of emissions are being seen from the response level that would dictate the change of frequency. But there's no hard and fast that you must do it on a specific item other than the guidance document. We talked about 3 days to begin, and maybe starting every week or some reasonable frequency to get it going. Get some good data.
And to go off of what Bruce is saying, it's sort of a fluid thing. You don't necessarily have to have anything set in stone. If you're finding that there are concerns either with the community or you have exceedances at some frequency that makes, site investigators feel that confirmatory sampling should be increased, you can do it 2 or 3 or 5 times a week. It really depends on site-specific conditions.
All right, I think that is all the time we have for questions. So thank you all for your participation. There were a lot of questions. So like we said before, if your question was not answered today during the training, don't worry. We will reach out in the coming weeks with answers to those questions because there were a lot of good ones in the chat. Tyrone, you can go to the next slide, please. We're just going to close out today with a few reminders. Tomorrow is day 2 of this training, so you have to register for day 2 separately from today's training. So if you only registered for today, but you want to attend tomorrow, make sure you register for that. And then also please fill out the course evaluation. Like I mentioned earlier, that feedback is really valuable to us and it helps us improve all of our trainings. So if you could fill that out, we would appreciate it. Next slide, please. And like I said, the questions not answered today will be answered in the coming weeks. Just a reminder that the LSRPA is responsible for issuing CEC certificates. That's not us. So you'll look out for an email from them for certificate access. And then also in the coming weeks, slides and presentation materials will be posted on our training page. So we thank you so much for attending today, and hopefully we will see you all tomorrow. Have a good night.